Good morning, ladies and gentlemen. Welcome back to Mr. Lee Physics class. So today what we will learn is potential meter. Ladies and gentlemen, the aim of the study today is to study the principle and use of the potential meter. Lesson objective. In this lesson, student learns the principle of the potential divider. Second, the principle of the potential meter. And objective number 3, to use the potential meter to make sure the EMF of a cell, determine the internal resistance of a cell, and finally compare resistance. Assume prior knowledge, students should be familiar with the effective resistance of two resistors in series. Next, the equation of V equal to IR, which is Ohm's law. 3, the meaning for EMF, electromotive force. And finally, the equation V equal to EMF minus IR, which is related to the internal resistance. Let's look at the slide. The slide shows a radio. This radio still in off mode. So what happened when we press the button, the on button? Let's observe what happened to the radio. We notice that when the radio is the on button is pressed, the radio produce music. And then what next I will do is I will adjust the volume level. I will slide the volume button, and then we observe what happened to the volume of the music. This means that when the the music button slide to right, the volume of the music increase, but when I slide to left, the volume of the music reduce until none. Let's go to the next slide. Now we look at the lamp, the ceiling lamp. So what happened when I turn the button, turn the switch? So when the switch is turned, the light become dimmer, the intensity reduced. Once I turn again, so since the bulb, the lamp is off. So it becomes dimmer until off. So turn again. So it becomes brighter and brighter until maximum intensity. So in this lesson, you will learn about the principle of the potential meter. All that just now related to some of the example of the potential meter. And we learn how the principle of the potentiometer and use the potentiometer to make sure the EMF of a cell, determine the internal resistance of a cell, and compare the resistance. Ladies and gentlemen, let's look at the next slide. We have the rheostat. We have a 12-volt cell. That means a battery, a switch, a bulb, and a voltmeter. If we want to assemble all this together, let's see how we assemble it. So now we notice that a battery is connected to the bulb, to a bulb in series. And a rheostat is connected in between these two wires, which the voltmeter maybe because we adjust, maybe shortcut or pass by the battery. So this this rheostat, if the slide, we let the current move from the, let's say, move from the battery up to the bulb and back to the, from positive terminal to the negative terminal. If the resistance is very high, less current flow. But if the resistance reduced, that means that the sum of the current will flow and become the short circuit. Okay, now, if the more current flow through the rheostat, that means that less current will be flow to the bulb, because the bulb and the rheostat are in parallel connection. They share the current together. Now observe what happens if I connect the switch. Now the bulb is not light up. Why? Because more current flow through the rheostat. So what I can do, let's observe once I reduce. When I move the, the slider from left to right, this means that I increase the resistance. Once I increase the resistance, this means that less current flow through the rheostat, and most of the current, the rest current, will flow through the bulb. So the current flow to the bulb increase and cause the bulb light up. Now we look at the connection of the circuit. Bulb now is not light up. No matter where I move, the bulb is not light up. Reason? What happened? If I connected, I replace the bulb with the voltmeter, with a voltmeter. Now we notice that the current actually increased. Now what happened is, we look at here, the rheostat and the voltmeter above here, they are in parallel. Once the resistance increase, the potential difference across the rheostat also increase, because they are in parallel. Because they are parallel to the battery. So what happened at the end? they will have the same potential difference. Maximum 12 watt, and maximum potential difference is 12 watt. Okay, next. What happens if I connect two identical resistors? Let's say identical, yeah. Okay, two identical resistors in series. First, in series connection, we know that the effective resistance is R1 plus R2. The current flow through each resistor are equal because the effective current is equal to the current that flow through the resistor 1 and also equal to the current flow through the resistor 2. EMF V total or V total voltage is equal to the potential difference across the resistor 1 and also across the resistor 2. Means our V total is the sum of V1 plus V2. Okay. Now we look at here current. Current flow through R1 and R2 is given by I equal to V over R1 plus R2. V means that it will be the total potential difference. The potential difference across the two resistors, which is equal to the EMF. Divide by the effective resistance of the resistors because they are in series connection. Once we get the current should be the effective current in the circuit I total. Where in series, both of them, I total equal to I1 equal to I2. Then we use the formula V1 equal to I times with R1 or V2 equal to I times with R2. So from here, what we can do, substitute I into the above equation. We put I into the above equation. That means that we put it in, we get that V over R1 plus R2 times with R1. That is potential difference. This formula actually is used to find out the ratio. Okay. V is equal to V over R1 plus R2. This means V, we can set that R1 over R1 plus R2 times with V is the V1. This means that the potential difference here, as we know that potential difference is directly proportional to the resistance against the potential difference V voltage is directly proportional to the resistance of R1. V1 is directly proportional to R1. So this means that we use that to find out the V1. This means we use the R1 times with V. The ratio of the potential difference, R1 over effective resistance total times with the V, the total potential difference. This means that we get the V1. Why we use this formula to find out the V1? Because if I use, for example, you look at here, V1 is equal to R1 over R1 plus R2 times with V. If I want to find the V2, this means R2 over R1 plus R2 times with V. Reason we use this type of formula is use the concept of ratio. Why? Because V total, the V, is equal to V1 plus V2. In series connection, the voltage are divided according to the ratio of the resistance. And next, now look at the potential divider circuit again. Let's say V1 here, V only. V1 is equal to R1 over R1 plus R2 V, where they give us R1 plus R2. That means that is equal to 12 ohms. The R1 plus R2 actually is the left side of the slider and right side of the slider. Left side of the slider is, okay, how much? We don't know, but R1 plus R2 is 12 watt now. It's 12 ohm. Okay, so once we connect, we found that, okay, if R1 equal to 3, that means that it will be 3. Sorry, it will be 3 over 12. 3 over 12 is equal to how much? So please, okay, help me to count it. Okay, that means 3 over 12 times with the voltage is 12. So we get that it will be 3 watt. Correct? Let's check it. Okay. If the R1 is equal to 6, what happened? We get that, we calculate, we get that it will be 6 watt. If 9 R1 is 9, replaced into the formula 9. 12 is come from the R1 plus R2 is 12. So times with the 12 watt. 12 watt, 12. Okay, times with 12 watt, we get that it will be 9. Okay, again, if it is 12, 12 over 12 is equal to 1. 1 times 12, so it will be 12 watt. Okay, that means that observe or not, you observe or not, every time when I move it, so the slide is moving. Again, because just now you just observe the, what I key in, but most of the student, I think, wow. Wow, yeah. Let me switch off some of the slides. Okay, now let's look at the connection. Once I connect, this is 3. Look at here, yeah. So 3, 3. What happened? That means the slider is somewhere here. Okay, just now it's from here. Now it's moved to somewhere here. So that means that, okay, it's for 3. What happens for 3, yeah? Because this one 6 seam is half already. If 6 means, well, the slider will be at the center. Okay, because total is 12, 6 should be at the center. R1 and R2, that means 6 R1. When it's 9, that means 3 over 4 of the total length. That means it should be 3 over 4. You notice or not? And finally, 12, that means that the slider of the rheostat will totally go to the right side. So that means it will be 12 watt. As a conclusion, we can say that a divider is used to tap a fraction of the supply voltage. Okay, and a rheostat or 2 resistors connected in series can be used as a potential meter. What is mean by potential divider? Divider, this means divide the voltage according to the portion or according to the ratio of the resistor. Ratio of the resistance. And the voltage V1 tap off from voltage V by the potential divider, we can use R1 over R1 plus R2 times with the total voltage. Then we get a V1. Same with V2. If V2 equal to R2 over R1 plus R2 times with V. What happens if 3 resistor? Okay, let's say if with 3 resistor, this means V1 equal to R1 over R1 plus R2 plus R3 times with V total. If there are 3 resistors connect in series. Okay. Now we look at the circuit. Now we are going to the principle of potential meter. Just now is potential divider, divide. Okay, we use resistor or we use the resistors to divide, much more than one. If potential meter, we notice that we use a battery. Okay, this one we use, okay, consider use accumulator. Why? Because accumulator can produce higher current and accumulator can give more stable current compared to the battery. Battery, once we connect like that, this means that without pass through any resistor, due to the short circuit and due to the internal resistance of the battery, so the output voltage will be lowered down until almost zero. So that's why we choose an accumulator to use to produce the electric current. Next, here we notice that we connect the we connect the battery, the terminal positive and terminal negative through a wire of 100 cm. That's in 1 meter long. So from here, the wire pass through. We use we attach a meter ruler scale along the wire. So the purpose we attach the ruler is used to make sure or used to determine the position of the divider of the point. Now we look at the next slide. The slide shows that now the current is flow. If we connect, that means that the current now is flow through the the wire. Current flow from out, flow out from the positive terminal along the wire, pass through the switch, go to the wire at the point A and go to the point B until along the wire until point B and back to the negative terminal. Now I connect another wire to a voltmeter and also the jockey. Okay, so now the current is not flow through the voltmeter and also the jockey. Why? Because there is no connection. Once I connect, I found that we notice the potential, the voltmeter, the reading of the voltmeter increased. Way from A to J, the distance increased. So this means that maximum, how much? Maximum will be the total voltage. 2 volt. Total voltage of the battery, same with the EMF. The current, that means that now you notice or not, if I connected the jockey, that means that the current is flow through the wire. Consider there is resistor 1 and also flow through the another resistor. So from here they will have the same voltage because the voltmeter and the voltage, the potential across the point AB are equal because they are in parallel. So when the AJ distance reduce, the potential also reduce. Conclusion: potential difference across AJ, the point AJ is directly proportional to the length L of the AJ, where VAJ, the voltage cross the point AJ will be equal to the length of the wire. Length of the wire over 100. Hey, what's mean by 100? Yeah, 100 cm. 100 is the total length of the wire. From A to B is the total length. Okay, times with 2 watt is the V total. Then we can set that AJ is directly proportional to the L. Why we use L? Why we don't just now? Just now we use the resistance, right? If potentiometer we use resistance, right? But why now we use the what's that? We use the length because actually we still using the resistance because as we learned before, resistance is directly proportional to the length. The longer the wire, the higher the resistance. The lower, the shorter the wire, the shorter the resistance. So this means that actually we are using R1 over R1 plus R2 because R1 plus R2 is 100 cm times with the resistance. Okay, so if times with the resistance, actually this one L times with resistance, 100 also times with resistance, then we cancel each other. Okay, so that's why we use the length. The length of the wire also can be used to find out the potential across the point AJ. As a conclusion, a potentiometer consists of a uniform wire, usually 1 meter long. No matter how much 1 meter long is more easier for us to solve it. Can we use 2 meter? And just how much AJ divided by the total length is 2 meter if we use 2 meter. Okay, 1 meter long, stretch between 2 terminals. Why must stretch? So that easier for us to measure. And the measurement of the length will be more accurate. A driver cell of constant EMF and a switch. Notice or not, we use a constant EMF. Don't use battery. Battery will not work well, cannot work well. So once we use it, so we use the potential, we use the voltage, okay, power supply with the 2 watt and 6 watt, okay, the stable to produce the stable current. So now the potential difference across the length L of the potentiometer wire is directly proportional to L. That means V is directly proportional to L. Why? Because V is directly proportional to the length. Why? Because the length is directly proportional to the resistance. As a conclusion, we can say that the potential difference V voltage is directly proportional to the length as well. Okay. So next. A voltmeter and a dry cell. So now we will learn how to use a voltmeter and a dry cell to determine the EMF. Okay, once we determine the EMF as we learned before in previous chapter, once the battery is connected directly to a voltmeter without any electronic device along the connection, connection wire. So we said that the measurement, the reading obtained by the voltmeter is the EMF or maximum voltage that produced by the battery. Now we look at here. What happened is, now I use the same 2 volt of accumulator. Accumulator means that the wet cell, not the dry cell, yeah. Okay, accumulator. So last time we can set that if we use this accumulator, last time we use the wet cell. The accumulator used by the almost same the concept used in car or used in the motorcycle. But nowadays, due to the technology, today's accumulator, most of the accumulator already become the dry cell condition. The wet cell rarely we cannot say that can't find. Okay, the number of the wet cell in market already reduced because most of the people nowadays they use the dry accumulator. Okay, ladies and gentlemen, what are the difference between the dry cell and the wet cell, or dry accumulator and the wet accumulator used in our car? Actually, both of them are equal. They have advantage and also have their own disadvantage. For example, wet cell, which still in water, yeah, in liquid type. So electrolyte in liquid type, there is a wet accumulator. The wet accumulator, the disadvantage is we need to refill the electrolyte, the water inside the battery. Don't let we cannot let the electrolyte dry off. If dry off, this means we spoil the battery. So that is one thing we need to take care. Advantage, it can use for longer. Okay, the lifespan is longer than the dry accumulator. Dry accumulator advantage, no need to take care, no need to refill the electrolyte, no need to worry about the electrolyte. But the lifespan normally is shorter than the wet accumulator. Okay, those are the difference. Depends on which type you want to use it. For me, I prefer the wet accumulator because I can save some money due to the long lifespan. Sometimes, for example, sometimes a dry accumulator can use for around 1.5 years. For the wet accumulator, it can use minimum around 2 to 3 years. Okay, so that is the reason why I still prefer the wet accumulator. Okay, now after we talk about the accumulator, now we go to the circuit. The circuit now is connected